Welcome to the project submission by roll number 7, roll number 15, and roll number 27. In this project, we had to make a line following robot that was only using multiplexers and motor driver. Here we will discuss about the contents of our presentation. First of all, we will have a brief introduction about the DLD project that we are making. Then we will discuss the components that we used in our project. After that, we will move on to the circuit design and layout. Then we will see the truth table of our project, then Kmap equation, and then we will describe the procedure that we followed throughout to make our line following robot. At the end, we will attach a working video. Then we will attach a price table of the components that we purchased from the market. Then after that, we will discuss the problems that we faced during the making of this project and the learning outcomes that were involved in this project. Talking about the introduction of our project, we had to make a line following robot. So basically, a line following robot is a machine that follows a line. It may be black line or a white line. So it's a robot that uses IR sensors to detect the light that is being reflected from the surface and then utilizes that light into different circuits and provides output to the motors, which in turns rotates the wheel and the robot moves. So this slide shows the components that we used in our project. Talking about the detail of the main components of our circuit, first of all we use the 74150 MUX. This is a multiplexer that takes 16 inputs and give us one output on the basis of selector pins. Then we used L293D motor driver. It basically drives the motors and converts the low ampere current rating into high ampere current rating for the working of the motors. The IR sensor which we use were in a package. They contained both a photodiode and a phototransistor, and they detected the light as well as emitted the light at the same time. These IR sensor in then created a main input that we fed to the multiplexers and got the output for the motor. The mux that we used was 74150 and it is a 5 volt rating, so we also used a voltage regulator that converts 12 volts to 5 volt fixed output voltage in order to ensure the safety of the mux. Moving on to the working of our project, we first had to make a schematic in the Proteus. So here is the Proteus design that we made for the project, and here is the PCB layout that we designed for our circuit. Then we got it printed on the piece of paper, and finally we printed it on a copper board. Keeping in view the logic of the left and right motor, we made a truth table for both of them, and here is the truth table that represents the presentation of when will right motor start and when will left motor start. Then using the following truth table, we also made a Kmap of the truth table and also the simplified equation for the left and right motor. Moving on from the logic, here we will describe how we actually made our project. Firstly, we made a Proteus circuit that we showed to you using the instructions given in the project details document. Then from the Proteus circuit we made a PCB design. It was also attached in the presentation. After that we got the PCB design printed on the PCB board. Then we ordered all the components of the PCB and soldered them. By installing the PCB on the chassis and doing connection of the motors and sensor, we completed our line following robot. Here is a working video of our project that will show the actual working of the project. We bought all the components from the local market, and here is the price table for all the components that we used in our project. Now we will discuss the problems that we faced during the making of this project. First of all, the circuit was very complex and we had to deal with it. After that, the PCB design that we made took a lot of time for us and for arranging the components properly. The making of PCB was a problem in itself as we do not have a lot of experience in that. After the completion of design, we had to face difficulty in the availability of components. The specifically 16 to 1 mux was really hard to find and we had to buy it at inflated prices. After the soldering, we had to face difficulty in adjusting the IR sensor as we had no previous knowledge about the working of IR sensors. The main aim of all the projects that we do is that we have some learning outcomes from that. So the first learning outcome from this project was that we learned to do the teamwork and a sense of responsibility, which was very prominent at the end of the project. As mentioned above, that we had no previous knowledge of IR sensors, so it was a new thing for us. We also learned the working of IR sensors with different circuit components. Then our Proteus and PCB making skills were also put to a test and were learned a lot through that. We learned the use of multiplexers in real life circuits and other complex applications. Also, the line following robot that seemed very complex at the beginning of the project seemed like an easy task at the end of this project, so we learned the working of a line following robot. Hence, at the end, we were able to make a line following robot, which was the main learning outcome of this project. So, that's all from our side. Thank you and have a nice day.